Hi, everybody. Welcome to week 7 of CAD for Electronics. This is Cad1133 and Cad2131 Proteus section. So today we're going to bite off the next piece of our project, and that's to deal with variants, to deal with bill of materials, to deal with additional parts, and to talk a little bit about the supply chain. All right. Design variants are a way for us to create one design that has multiple uses or multiple cases. So for example, when you buy a car, it may come with intermittent wipers or it may not. That doesn't mean that the car manufacturer has created two full cars, that one has intermittent wipers and one doesn't. They basically enable a switch to be put in, or even worse, sometimes it's just a software upgrade that costs you lots of money. We can do the same, but we have different reasons why we would want to do this. For example, quite often when I'm creating a design, I'll have parts that are there not for production, but for prototyping and testing, and so part of it will be design a variant that I usually call production, which will have all of the extraneous bits that were there for my testing removed. Okay, so what we want to do now is we want to create some variants of our own. So the reason being is the first year we don't need to populate everything. We're only interested in doing a portion of our design, but we do want to still have the PCB layout and the schematic and everything, but we don't want the bill of materials to include this. And so what we're going to do is we're going to go under Design Explorer, and we're going to create some new variants. Okay, so here we go. Variant, add a variant, and in this case we'll call it first year, second year, and third year. We can now go through each of our boards and choose what we want for each variant. And so in first year, obviously we don't need a lot of the components, but we do want others. And so what I encourage you to do is to go through, select these parts that you see here on the screen as your year one variant. Everything else can be left off. You can enable it for year 2 or 3 if you wish, but basically these are the parts that I need in my year 1 variant. All right. So pause the video, go do that if you want, or come back to it as part of your homework. That's fine. But what I want to talk to you about next needs to be done before you get into your bill of materials. And that's to use a tool called the Auto Annotate. And it's a really powerful tool. You can imagine that I have my design and I've been laying out my power supply, for example, and it makes perfect sense to me. I have D1, D2, D3, D4, and so on and so forth. How do I go about finding D6? And so in this case, where I have my schematic, I could right click on it and say highlight on my PCB, and it would take me to D6. But when I go to populate this, it would be very convenient if D1 was in a predictable place and D99 was in another predictable place. And so the tool that we want to use is the Automatic Annotator, and it's here under Tools, and not to be confused with the Automatic Name Generator. It's the Automatic Annotator. And we can decide how we want to do it. I like to go from top to bottom, left to right, but if you want to do yours differently, that's fine. And basically, it's going to do the component side first and then the solder side. So if you had a double loaded board, so parts on the top, parts on the bottom, but all of our parts should be on the top. Incidentally, if you do have parts that are magenta instead of cyan, they are on the bottom of the board, and so be aware of that. But here we go. Tools, Annotator, and we'll just say okay. And what this will do is not only will it shuffle the labels around here on the circuit board, but it will update it on your schematic as well as in your bill of materials, which we haven't really talked about. Okay, so let's, because I touched on it, let's take a second and think about where our parts are on the board. And so hopefully you've gotten some feedback from me at this point on your PCB layout. If I did mention that your parts are on the wrong side, what I'm referring to is if you take a look at the circuit board itself using the 3D viewer, all your parts should be on this side of the board. If you see parts on this side of the board and it's intentional, that's great. If it's not, you might want to fix that. And the easy way to fix it is to actually mirror the part. So for example, if I, let me just grab a part here. And so if I lay this part on, this footprint on here, if I mirror it, notice that it turns magenta. And when I go to my PCB layout, I flip the board over, sure enough, there's my poor lowly capacitor on the wrong side. In this case, it wouldn't make a whole lot of difference because it's a 2-pin symmetrical device. I could just put it on the correct side of the board, but if I put my microprocessor on the wrong side of the board, that's going to be a problem. All right. So be aware of that. Often we have circuit boards that have multiple voltages on one board, on one design. And the reason we do that is because we want to have high voltage and low current running everywhere that we can across the circuit board, because power is voltage times current. If we're delivering X number of watts to a chip, it's much easier to bring in, let's argue, a 12-volt line to that chip, and then at that chip, step it down to say 1.2 volts. And so if we took our 12 volts at 1 amp and we stepped it down using a buck regulator, we would change that to 1.2 volts at 10 amps. And so things like FPGAs that require a lot of power now benefit from this low current right up to the device, and then very short high current traces to the power pins. And so we want to be able to set this up. And let's do a little example here. I'm going to create two powers here. There we go, two of them, and just for argument's sake, I will throw in a couple of resistors. And we'll run them to ground. Now, one of them is going to be set up with our default at 3.3 volts, but let's argue the other one we wanted 9 volts. And if I try to simulate this right now, it's going to say that there's a problem, that there is no power supply specified as 9 volts. And so what we need to do in this case is to go in to our design to configure the power rail, and we want to actually create a new power rail. Okay, so new, and we'll call this one 9 volt. And you can see that it's smart enough to figure out that we're trying to make something at 9 volts. And so that's fantastic. And we have this 9 volt that's existing here. And so we just want to actually connect that. Easy enough. Now when we try to simulate it, it's not going to give us that error anymore. Matter of fact, my simulation is up and running. You can see my real-time clock is happy. A very, very powerful tool to be able to pull around lots of different voltages. All right. Okay, the next thing that I want to talk to you about is tidying up. So you may have pulled in a lot of parts over here on the left-hand side, and it's getting quite big and messy. So one of the things that we can do is if you just simply right-click and press tidy, it will remove all of the unused devices from our list. We can do the same here with our PCB layout. We can tidy this up, and it will remove all of the unused items from our list. And that may be a good thing or might be a bad thing. This is something you do kind of towards the end of your project so that it's nice and neat and tidy for the next person that needs to look at. Okay, the next one's a doozy. Let's get into the bill of materials. This is going to eat up days of your life if you end up getting into PCB layouts. A lot of time is spent making sure that the bill of materials is accurate, up to date, and that the parts that you've picked are actually attainable. Okay, quite often we go at and pick some arbitrary values. For example, a capacitor. You might choose an electrolytic capacitor with a certain footprint, a certain value, and you find out that the value is not available, the footprint's not available, or a combination thereof. And it may be that it's not made. It may be that there's not stock. It may be that it's cost inhibitive. Okay, so we're still in the fluid part of our design where we start to really dig into this. And so how do we create it? Basically, this button here will open up our bill of materials. Okay, so when we open it up, it should look something like this. And it's kind of sort of okay as long as you don't want to ever put it in a binder or use it with more information than what we have here. And so we're going to add a couple fields to it. We're going to change the format and make it, in my opinion, a little nicer to use. All right. So let's go in and start by creating a couple things. The first one that I want to do is I want to change the layout and how it looks. And so we're going to start by going up here to the little piece of paper, it looks like. And we want to change it over to letter. That's important. And we're going to change it to landscape mode from portrait, okay? And on the left and right margin and the bottom, I want 1/2 inch and 1.25 inches at the top. And what that'll do is give you room up here for a 3-hole paper punch and a nice little bit of margin around to write anything in if you need to. Okay, so let's add some more information to this. For example, we want to add the footprint to make sure that when we're ordering parts, it matches up. And so what we want to do is use the little plus symbol here, open this up, and we can create or add a package. Okay. And we'll call it PCB package, and we'll say, okay. And you'll notice here that it actually says that this is a Res 40, which is ideal. And here we go, PCB package. And we can move it around. If you don't like its location, you can move it up and down. So whenever we're working with the property editor here in our bill of materials and we make some modification, so for example, we can now add stock codes, which you would get from the manufacturer, and you could possibly put in a link. Okay. Remember that you have to apply your changes all the time, so that it's actually kept. let's say that this is good for now. What we want to do next is we actually want to save this template file. And so I recommend you save it as a new file, and we'll call this one Durham. All right. And there's a lot of stuff that you can do with this. You could put the company logo or the school logo up here, or your personal identifier. And that's fantastic. That's great. The other thing that you can do or should do is if you haven't already put the author name in, it will put it in here. So if we go back to my schematic, go to design, edit design properties, and under Arthur, put in Scott, give it a title, Lab 7, and we'll give this a revision, B0.1. We'll say OK. When we go back to our bill of materials, you'll see that it does actually update all of those fields for us. All right. Okay, so we're going to want to add some extra parts to this. For example, the microprocessor is going to want to have a socket. Okay, you may need a heat sink on a transistor. We don't today, but you've created a battery holder. It would be nice to have a battery that goes along with it. And so, how do we go at creating some extra parts to this? And the way that we do that is here in the property editor. We would actually add some new parts. And so in this case, we could add a part that's associated with maybe the microprocessor. So use something or other. I'm just going to associate something with R1, and I'm going to give it a prefix of mechanical and a value of 1. So now I'm going to create this new thing. And so this could be a heat sink or something, but we can put in some stock value and associate a part link with this. All right. And we can also associate costs with all of this. Obviously, if we do have a part associated with some ancillaries, whether it be nuts and bolts or a heat sink in this case, we want to show that here in our total costs, right? So in this case, we have resistors that are worth 25 cents each. We have 5 of them, so $1.25 plus $1.50 for this mechanical widget under miscellaneous to bring us to $2.75. Very important to think of all the things and parts that you need. Okay, so how to output our bill of materials? A couple ways. One is you can output directly as a PDF. You can send it directly to the printer, or you can send it to an Excel file. And Excel files are great if you need to send it to a manufacturer and you want to be able to edit it and modify it. A lot of PCB manufacturers will want this in an Excel format. So this is how you would do it. You could also send it as a comma separated variable file, so a CSV, or as a text document. Okay, so for your homework, I'd like you to complete the bill of materials for the first year variant only. And I do want you to go on to a reputable website, find a link and a part number for it, and submit it as a PDF for review, and I will review it and get it back to you with suggestions or comments. Okay, make sure that you do look at the MOQ, so the minimum ordering quantity. Make sure that you look at the stock available, and do keep an eye on the footprint and the costs. Okay, so let me walk you through one component here, and you'll kind of get the idea. So I'm on DigiKey. You don't have to use DigiKey. You can use any of the other manufacturers or suppliers, but I'm just here. So let's look for a 10K resistor. That seems like a reasonable start. We know that it's going to be a through-hole part, and we're looking for something that is going to be in stock and normally stocking. And let's see. We also want it to be an axial package. We're starting to narrow things down. We can make sure that we are at a 10K resistor. And let's start by applying these. Okay. And so we've got some expensive things, some inexpensive things, but we do want to be aware of what exactly we're looking at. And so this package would be fine. This package is too long, right? It's 0.6 of an inch, and a Res 40 is only 0.4 of an inch. So something in this size would be good. So let's take a look at our packages here, and make sure that we pick something that's going to be smaller than 0.4 in length. So let's grab all of these guys here, and that should be good. And the other thing that we can think about is the power dissipation. So 0.1 of a watt to a quarter watt should be good enough. And let's apply these. And so you can see that we've been able to narrow it down rather quickly to a few items. The next thing that we want to do is we want to order a set value of these. So let's say we want 5 of them. And so we're able to look at the MOQ. So the minimum order quantity is only 1. So we're good there. The cost is only 5 cents a piece at 10 units. And there's 1 million of them in stock. So this seems like a fairly good option for us to choose. And so we could go in and take a look at the data sheet, which would be a good idea if this was something special. It's not, so we're not going to worry about it too awfully much. And so I'm just going to take this and pin it here. And we're going to take a look at our bill of materials property editor. And so in this case, we want the part number. So I'm going to Control-C, copy it, and paste it here. And I want to copy the link and paste it here. And we can now update our costing, right? We're now 0.54 of a cent. Okay, so 0.54. And so 0.4 of a cent doesn't seem like anything, but it does start to add up towards the end. And so now I'm going to apply my changes. And what that does for me is now when we look at our costing, it's updated there. And the nice thing is that I have a link so that I can go directly to that website when it's time to order my parts. So very, very handy, powerful tool. And as you can imagine, it starts to eat up a fair bit of time sourcing all of these parts. And if something's not available, then you can go back and modify your schematic accordingly. Okay, so for your homework, I want you to create a complete bill of material for the first year variant, including costing, part numbers, and links. I want you to output it as a PDF for me to review and grade, and I'll get back to you with it for next week. And in the meantime, I'm going to provide to you information on the project. So basically, I'm making available this week the material for the in a PDF format for the schematic, my PCB design, and I think next week I will provide for you my bill of materials so that you can reference it. Once your PCB is finished and cleaned up, if available, we'll have circuit boards for you to pick up, and you can then, once I approve your bill of materials, order the parts from DigiKey or Mouser or Allied or Electrosonic or anybody you want. I recommend avoiding places like Alibaba, Made in China, Made in India, Wish, anything like that. Avoid at all costs. But it's available. But now that we're finishing stuff up, we can start to think about getting your project finished. And we do have a work week available, but all of the major components for your project are finished now. And so you've got a couple weeks to get everything finished and buttoned up, but your final submission for your project is going to be due, and know that we do have some timelines that we have to be aware of, because I have to get the grades submitted. So anything that I need to send back to you, we need to get finished as soon as possible. All right. Subject to change, you're going to find a document that looks like this on DC Connect. And basically what I want you to do is do a self-evaluation. Okay, how do you think you did? And then when you make your final submission, I want you to send me this Excel spreadsheet filled in with the self-evaluation, and we'll give some marks to that. Obviously, if we're not able to be face-to-face, then the marking scheme is going to change. So this is for reference. All right. So as always, if you have questions, concerns, comments, suggestions, please feel free to send me an email. My email box is always open, and I welcome your input. If you're having trouble, difficulties, definitely send me an email right away. Let's get you back on track if you're having an issue, and hopefully you're really enjoying this course and plowing forward with what is in essence a very complicated project. All right. So thanks for watching. Have yourself a great day. All right. Bye now.